Welcome to This Explainer, your absolute ultimate college algebra bootcamp. Look, if you're staring down the barrel of those summer exams and feeling, well, maybe a little overwhelmed by the sheer mountain of formulas, you are in exactly the right place. Today, we aren't just going to look at the math. No, we are going to learn how to actively conquer it. We're going to focus heavily on how to physically execute the mathematical steps right there on your paper. Because as you probably know, in an exam setting, simply knowing that final answer, it's just not enough. Showing you're working, clearly and logically, is how you actually secure those maximum points. So, grab your scratch pad, because we are getting right to work.
All right, here's our study guide for today. We'll be tackling 1. Rules of exponents, 2. Solving linear equations, 3. Powering through polynomials, 4. Factoring and finding roots, and 5. Mastering complex numbers. We're building momentum systematically, saving the final boss, complex numbers, for the very end. Let's get into it.
Section 1. Rules of exponents. Let's dive right in and lay down the foundational laws you absolutely need to memorize to survive a college algebra test.
Okay, so take a look at the core rules you need in your toolkit. We've got the product rule, where multiplying identical bases means you just add the exponents, right? Then there's the quotient rule, where division means subtracting them. You also absolutely need to know how to handle powers of products and quotients, but actually, look down at the bottom of the list. Those last two? Total exam traps. Anything to the power of 0 is 1, always. And a negative exponent, like a to the negative n, well, that flips into a fraction, becoming 1 over a to the positive n. Let me tell you, examiners love testing if you remember to flip that negative exponent.
Let's actually put those rules to the test right now. Pause for a second and try to solve these two problems in your head, or, just jot them down quickly. First, how do you simplify b to the 5th times b to the negative 2? And second, how about xy, all in parentheses, to the 4th, multiplied by x squared? Think back to the product rule and the power of a product rule we literally just talked about. So, let's see how you did. For that first problem, we apply the product rule. Now remember, for the exam, you physically write out b to the power of 5 plus negative 2, showing that specific addition step is absolutely vital for grading. 5 plus negative 2 is 3, giving us b cubed. Boom, done. For the second one, you first distribute that power of 4 to both the x and the y inside the parentheses. That gives you x to the 4th, y to the 4th. Then you combine the x terms by adding their exponents. 4 plus 2 is 6. So the final answer is x to the 6th, y to the 4th. Trust me, if you can clearly show those middle steps on your exam, you are golden.
Moving right along to Section 2, Solving Linear Equations. Now that we've warmed up our algebraic muscles a bit, let's look at isolating variables.
What's really cool here is how these examples perfectly model the exact step-by-step working required on a test. Just look directly at problem number 9, x over 2 minus 1 equals 5. Now, an amateur might just scribble x equals 12, but an exam master, they write the text underneath. They literally write add 1 to both sides, so x over 2 equals 6. Then multiply by 2, so x equals 12. You see, the golden rule of algebra is whatever you do to one side, you've got to do the exact same thing to the other. Explicitly stating those operations, like dividing both sides by negative 3 in question 10, is literally the foolproof path to sweeping up every single point available on that grading rubric. Make it basically impossible for the grader to misunderstand your logic.
All right, Section 3, Powering Through Polynomials. It's time to face the mid-level boss of our exam review. Let's break down exactly what a polynomial actually is. It's essentially just a chain of mathematical operations, variables and coefficients linked together purely by addition, subtraction, and multiplication. But here's the catch. The exponents absolutely must be non-negative integers. So no fractions, no negative powers allowed here. Now, the absolutely crucial point for your exam is this final bullet point, standard form. Whenever you finish a calculation with polynomials, you have to arrange your terms in descending order of their exponents. Start with your cube term, then your squared term, then the single variable, all the way down to the constant. Honestly, it just shows a level of mathematical maturity to the person grading your paper.
You also need to be able to classify these things on site based on their highest degree, which is really just a fancy way of saying their highest exponent. If the highest power is 0, meaning it's just a plain number, like y equals c, it's a constant. A highest power of 1? That's a linear equation. A power of 2 is a quadratic, which, let's be real, you will see constantly. And a highest power of 3 makes it a cubic polynomial. Recognizing these instantly tells you exactly what kind of graph you'd be drawing and what specific solving tools you need to pull from your brain.
Which brings us to Section 4, Factoring and Finding Roots. Let's see how to break these complex polynomials down into manageable pieces.
I know factoring can cause a ton of panic during a time test. We've all been there. But whenever you're asked to simplify a scary-looking rational expression, I want you to just take a deep breath and follow these 3 highly mechanical steps. Step 1, factor the expression. Just break it down into its smallest prime components. Step 2, visually identify and isolate any terms that are common to both the top and the bottom. And step 3, simply cancel those common factors out. It really is that systematic.
Look at how beautifully this works in practice. Let's take question 1, 12x to the 4th over 42x. Instead of trying to do it all in your head and risking a silly mistake, just write out the factored form. Break the 12 down into 2 times 6 and the x to the 4th into x times x cubed. Then, break the 42 down into 7 times 6. Suddenly, it's like magic. The common terms of 6 and x on both the numerator and denominator become totally obvious. You draw a line straight through them and you're left with 2x cubed over 7. Showing this expansion step is hands down the ultimate way to prove to your professor that you actually understand the underlying mechanics of division in algebra.
And we apply that exact same 3-step logic to heavier expressions, like the binomials right here. Take a look at question 7. X squared minus 9 over x plus 3. If you've been doing your practice, your brain should immediately flag x squared minus 9 as a difference of squares. So you factor the numerator into x minus 3 times x plus 3. Next, you look at the denominator, spot that matching x plus 3, and just neatly cancel them out. What started as a really messy fraction simplifies cleanly into just x minus 3. Again, I can't stress this enough. Writing out those bracketed factors before crossing them out is what guarantees your grade.
Now, a quick coach's tip straight from the professor's notes. The terminology on exams can honestly trip up even the most prepared students. So, remember, if a test question asks you to find the zeros of a polynomial, it's literally just asking you to find the roots. They are the exact same thing. It's just the x values where the graph crosses the x-axis and the y value equals 0. Do not let a simple synonym cost you easy points. Also, if you're dealing with a quadratic equation and you need to quickly check the nature of its roots before committing to this whole long solving process, just use the discriminant formula outlined right here in this table. The discriminant, or d, is equal to b squared minus 4ac. If you crunch those numbers and it exactly equals 0, you know the roots are equal. The graph just touches the x-axis once. If d is greater than 0, you've got 2 real distinct roots. And if d is less than 0, meaning you'd have a negative number under the square root in your quadratic formula, your roots are complex. Speaking of complex,
that brings us to Section 5, Mastering Complex Numbers. We have officially arrived at the climax of our explainer, the final boss of college algebra.
To truly master complex numbers, you need to be completely comfortable performing all 6 of these standard algebraic operations. You've got to be able to add them, subtract them, multiply, divide, and find their inverses. But let me let you in on a little secret based on decades of exam data. Multiplication is the specific operation where students usually get tangled up in their own notation and lose really valuable marks.
so let's practice this right now. Seriously, grab a piece of scratch paper and see if you can map out the actual multiplication steps for this exact exam-level problem. How do you show the working to multiply the complex number 2 plus 3i by 4 plus 5i? Think about the FOIL distribution method you learned for binomials and see if you can get to the final simplified answer before we go ahead and reveal it.
All right, here's the flawless step-by-step execution you should have written down. You use the FOIL method, first, outer, inner, last, to distribute all the terms. So 2 times 4 is 8, 2 times 5i is 10i, 3i times 4 is 12i, and 3i times 5i is 15i squared. Now listen to me. You must write out that entire expanded line on your test. Then comes the real magic trick. You absolutely must remember that I squared is equal to -1. That transforms your plus 15i squared into a simple minus 15. Then you just combine your real numbers, 8 minus 15 gives you -7, and combine your imaginary numbers to get 22i. The final correct answer is -7 plus 22i. Now that is beautifully logical, step-by-step math.
So, if you take away nothing else from this entire explainer, please let it be this exam strategy right here. Memorizing the formulas is realistically only half the battle. Stating the rule you're using, explicitly writing down the logical expansion steps, and boldly showing your factor cancellations, that is what actually secures your grade. An exam paper isn't just about the final number. It's essentially a document where you're arguing to the grader that you completely understand the mechanics of algebra, not just the final destination. We have covered exponent laws, balancing linear equations, taming polynomials, the mechanics of factoring, and the magic of complex multiplication. You now have the structure and the strategy to completely dismantle your final exam. Review these steps, trust your step-by-step working, and go absolutely ace that test. But before you go, I want to leave you with a quick question to think about. If algebra is essentially just the logical language of the universe, what real-world problems will you decode once you've fully mastered these foundational rules?